Okay, so in this lesson, we're going to be talking about applying algebra, our learning intentions, to be able to model simple situations using algebra, to be able to write expressions from descriptions, to understand that applying a model requires defining what the variables stand for. Let's just first talk about some theory here. Different situations can be modeled with algebraic expressions. To apply a rule, the variables should first be clearly defined. The known values are substituted for the variables. Okay, so let's go through some examples here. Here is our first example, which is asking us to write an expression for the following situations. So we have to write an expression for the following situations. The total cost of K bottles if each bottle costs $4. Well, if each bottle costs $4 and I'm buying K amount of them, that's 4 times K. And remember, in algebra, we don't like writing this multiplication sign, so we would simply write it as 4K. So that right there would be our answer. That would be the expression that represents this description here. Now, if we found out how many bottles we bought, let's say we bought 5 bottles, then we would say let K equal 5. So that would mean they would say the total cost of 5 bottles if each bottle costs $4. So to answer this, we would take the 5 and we would substitute it into the K spot. So we would end up with 4 times 5. 4 times 5 is 20, and it's going to be $20. Let's now go on to the next question, which says the perimeter of this triangle. Here is our triangle right here. And as you can see, I have one side of X, one side of Y, and this side doesn't say how long it is, but we have a dash here. And this dash is saying that, hey, I'm the same as this dash over here, which we know is X. If we're going to write the perimeter of it, we're just going to add up all the sides. So it's going to be X plus Y. Remember, you always want to simplify by gathering like terms. X plus X is 2X. Then I've got this plus Y here as well. So that is going to be my answer. And, you know, if we knew what the known values of X and Y are, so let's just make them up. Let's say X was equal to 1 and Y is equal to 2. I could sub those into my expression. So I'd get 2, 1 plus 2 here, which is going to be 2 times 1 is 2 plus 2. That's going to be 4. So 4 would be my answer if X is equal to 1 and Y is equal to 2. So that's the power of these expressions. Okay, let's keep on moving here. Here it says, write an expression for the following situations. And I'm going to get a highlighter out here and highlight the key terms. The area of a rectangle, if its length is 2 centimeters more than its width, and its width is X centimeters. Okay, so whenever you're in these situations, it is always helpful just to draw yourself a little rough diagram. So here's a rectangle because the question says rectangle. And we know that the width of this rectangle is X centimeters. So let's put that in X, which means this is also X. We're then told that the length is 2 centimeters more than its width. So here's our length. And we know, if we know that the length is 2 centimeters more than the width, then we could say it's going to be X plus 2. X plus 2. And just like that, we have a diagram that represents what we're doing. If you're struggling to understand what we did here, what we've been told is that the width is equal to X and that the length is equal to the width plus 2. So it's going to be X plus 2. Now, we need to figure out what the area is. And remember, area is width times length. Now, if I know that the width is X and I know that the length is X plus 2, it's going to look like this. Now make sure you put in brackets here because what it's saying is you're going to get the width and times it by the entire length. Otherwise, what you'll end up with is X times X and everything starts to break down. Now, a better way to write this is without the multiplication sign, which is just going to be like this. That is going to be your answer. X brackets X plus 2. All right, let's now answer our next one. And again, it's always a good idea to get out a highlighter and highlight the key terms. The perimeter of a rectangle, if its width is X centimeters and its length is 3 centimeters more than its width. Okay, so in this situation now, let's again begin by just drawing it out. We're told that we have a rectangle. We're told that the width is x centimeters. We're told that the length is 3 centimeters longer than the width. So that means this is going to be x plus 3, and this is going to be x plus 3. Now, this time, we're after the perimeter. To find the perimeter, I just add up all the sides. So that means I'm going to get x plus x, x plus x, plus x plus 3, plus x plus 3. Now, as I said before, you always want to simplify by gathering like terms. So here I have x, and x, and x, and x. I have 4 x's. So instead of writing x plus x plus x plus x, let's write 4x. And as you can also see, I have 2 constants there. I have plus 3 and plus 3. Plus 3, that's going to be plus 6. Plus 6. And that is going to be my answer. Now, there's also another way of representing this answer. So, or we could factorize it. So we could take out the highest common factor of 2 here, which would leave me with 2x and plus 3. That could be another answer. 2 times 2x is 4x, 2 times 3 is 6. So there are 2 different expressions that represent the same thing. Just one is expanded and one is factorized. Okay, let's keep on going now. Here we have example 3, which says, and let me get my highlighter out. It says a plumber charges a $60 call-out fee plus $50 per hour. We need to write an expression for a T-hour job. Now, a $60 call-out fee. That means it costs $60 just for the plumber to turn up. It's $60 just for them to turn up. No work, just to come to your place. It costs $60, a $60 call-out fee. Then it says plus, so plus $50 per hour. So it's $50 per hour, so times T, because we're told that it's a T-hour job. A better way to write this is 60 plus 50T. And that is our answer. And I really want to make sure that you understand the 2 parts of this. This 60 here is the call-out fee. It's the amount of money you have to pay just for a tradesman to turn up. Call-out fee. And then the other part of it is this, which is the cost per hour. So the tradesperson doesn't just want to be paid for, just for turning up. If they spend 3 hours, they want to be paid for a 3-hour job. Or if they spend 5 hours, they want to be paid for a 5-hour job. So this is the cost per hour. And you're going to find that when we're writing expressions, other expressions are going to follow a similar idea of having a fixed fee plus a fee that goes up for how many hours you're working or how far you've traveled or something like that. Okay, now it says write an expression, use the expression, so this one right here, to find how much a 5-hour job would cost. So we're going to use the expression, so we're going to rewrite it. And now we're asked to find how much a 5-hour job would cost. So I'm going to take this 5 and I'm going to put it into the T spot. So it's going to be 60 plus 50, and then I'm going to put a 5 in here. All right, so I'm going to get 60 plus 50 times 5 is 250. 60 plus 250 is going to be $310. That's going to be my answer. So as you can see, I did this by substitution. All right, let's move on to our next one. This is example 4. Let's get the highlighter out. It says the total time in minutes, if it takes, the total time in minutes it takes to paint K square meters of fencing, given that it takes 20 minutes to set up the painting equipment and then 5 minutes per square meter. All right, so we have to write an expression that represents this. So if it takes 20 minutes to set up the painting equipment, that means regardless of how much they're painting, it's going to take 20 minutes just for them to set up. And then it takes an additional 5 minutes per square meter. So that's going to be 5 times, and as you can see here, this is K square meters of fencing. So that means we're going to put a K here. So that means my final answer is going to be 20 plus 5K. And as you can see, this follows the same logic as our above example, in which we have a fixed time of 20 minutes just to set up. And then it has the time, like 5 times how long you're doing. So kind of a per hour or per distance, or in this case, per square meter. 5 minutes per square meter. So you got those 2 sections there. All right, now find the total time for painting a 5 square. Let me read that again. Find the total time for painting 5 square meters of fencing. So we're going to use our expression, and we're going to put 5 into the K spot. So I'm going to get 20 plus 5. Then I'm going to get 20 plus 5 times 5 is 25. That means it's going to take 45, and make sure you always put units. It's going to take 45 minutes. Perfect. So as you can see here, you first create the expression, and then when you're told a variable, so in this case you're told that k is equal to 5, you can sub that in. All right, let's keep on going. This is our last example here. It says, write an expression for the total area of the shape shown. So here is our shape shown. We have to write an expression for the total area. Now, we've already seen an example like this before in our expanding brackets lesson. We know that there are 2 ways of writing an expression for this. The first way we could do it is by treating these as 2 separate areas. So we have this area right here. Whoops. And then we have this area here as well. A1 is just going to be 12 times A. So A1 is just 12 times A, which is 12A. Then we're going to plus onto that A2, which is going to be 3. And let me just come over here for a second. A2 is going to be 3 times 12, because this is going to be 12 because it's the same length as that. 3 times 12 is 36. The other way we could write an expression for this is by treating it as one area. In this case, remember our area is our width times our length. Our width is 12, and our length is going to be, if I can draw a straight line, is going to be this right here. And as you can see, it has 2 sections. It has this A section, and it has this 3 section. So we're going to plus 3. And then we're going to put brackets around it because we want to treat it as one whole. It's the width times the entire length. And a better way to write that is like this, without the multiplication sign. That is one expression. That is another expression. These expressions are equivalent, and we're going to be seeing that very soon in practice. So the last thing we have to do here, if A is equal to 4, what is the area going to be? So let's use our first expression here. So 12A plus 36. So what we're going to do here is let A equal 4. So we're going to get 12, 4 plus 36. What is 12 times 4? It is 48 plus 36. What is 48 plus 36? It is going to be 8. Whoa, what happened there? It's going to be 84. 84. That would be our answer. If we were to use our other expression here, so that means we're using 12A plus 3. If I put 4 into my A spot here, I'm going to get this. 4 plus 3 is 12, so it's going to be 4 plus 3 is 7, 12 times 7, 12 times 7 is 84. So as you can see, we get the same answer. We get 84, and that's because the 2 expressions are the same. They're equivalent, so obviously when I sub in the same thing into them both, I'm going to get the same answer out. And be careful here, even though we haven't been specified the units, sometimes it's safe, because it is area, you might just want to write like units squared, because it is area. Perfect. I think we're hanging off the page a little bit there, so we just have to make sure that we write that a bit more concisely next time. But with all that being said, hopefully you found this lesson helpful in applying algebra. What we have covered is, are you able to model simple situations using algebra? Are you able to write expressions from descriptions? And are you able to understand that are you able to understand that applying a model requires defining what the variables stand for? Perfect. With all that being said, hopefully you found this useful, and I will see you in the next lesson.